Let's do the next question. There is a sphere. This is an insulated sphere and its radius is r is 14 centimeter. Now we need to increase the potential of this. Now how do we increase the potential of this so that the surface charge density we write it as sigma. So surface charge density goes up to 1 microcoulomb per meter square. How do we do this? So let's remember the formula which we derived. V equals 1 by 4 pi epsilon naught to Q by R. Q is nothing but, so let's go for the formula for surface charge density. Is given by charge by area of the surface area. So Q is equal to sigma S. So this is sigma. That way V will be equal to 1 by 4 pi epsilon naught is 9 into 10 to the power 9 multiplied by, let's look at the surface area. Surface area of a sphere, S equals 4 pi r square. 4 into 22 by 7 into r is 14 into 10 to the power minus 2 because it's in centimeter. That's squared. And then we also multiply it by the surface charge density, which is 1 into 10 to the power minus 6 because that is in microcoulomb. When you do that, you will get an answer for, and when you solve it, you get an answer 15840 volt. Now let's go for question number 6. There is a charge of Q which is equal to 6 into 10 to the power minus 6 coulomb or 6 microcoulomb. This charge is given to a hollow metallic sphere. So this is a metallic sphere. So this charge is given to this, and it has a radius of 0.2 meter. Now we have to find the potential at surface and then potential at center. Potential is given by 1 by 4 pi epsilon naught into Q by R. This is the potential at the surface, which is equals 9 into 10 to the power 9. Q is 6 into 10 to the power minus 6 by R is 0.2. When you do that, you get 2.7 into 10 to the power 5 volt. So this is a potential we are speaking about at the surface. However, we also saw already the potential at center is equal to the potential at surface. So inside also same thing only. So it is the same thing actually inside as well. As a result, potential at surface, potential at the center both equal to 2.7 into 10 to the power 5 volt. Let us go for the next question. There are some drops and there are 27 of them. 27 such drops, and each of the drop is getting charged with 220 volts. And all of them come together and they come together and form a big drop. we need to calculate the V of this, the potential of this bigger drop. Now let's say the smaller drops, okay, the smaller drops, they have a radius of r. I'm showing the diameter here, but radius is r. Okay, the small drops have a radius of r. Now when there are 27 of them, they come together and combine, they come together, they all come together and form this big drop, and this has a radius of, let me show it inside, radius of capital R. Now the volume of this droplets have not changed. 27 of them come together and combine, the volume will remain the same, it's just the shape have changed. So the larger volume is 1 by 4 by 3 pi r cube, and the smaller volume is 27 times that of 4 by 3 pi r cube. When you do this, you will see that the larger radius is 3 times that of the smaller radius. So the formula for potential is 1 by 4 pi epsilon naught into Q by R. Let's keep it as K. So V is equal to KQ by R. This already equals 220. Now the potential of the larger one, now let's say this is the smaller droplets, the larger one is equals KQ by R, which is K into 27 times the original charge by, and this R is 3R, which is, we will get 9 into KQ by R, or 9 into 220 volts, which equals 1980 volts. There is another question, an interesting one. There are two small balls like this, and they are conducting balls made of metals, conducting balls. And let's call the small conducting balls as A and B. And each of them, they have a radius of R1 and R2. They also have charges of Q1 and Q2. They are, they are connected by a wire like this. Now we have to obtain an expression for charges. We have to obtain an expression. We have to create an expression for the charges on A and B when they are in equilibrium. We are not speaking about any other situation. We are speaking about particular situation, that is equilibrium. Now let's look at this. This is our setup. Two charges, two conducting balls connected by a wire, and they are in equilibrium. Now when we say equilibrium, so firstly you should remember the conservation of charge. So the charge is not going to be created or destroyed. It can only be redistributed. That means before the charges were connected, the entire system would have had a total charge before they were both connected. That is the initial charge. And after they were connected together, there would have been some redistribution of the charges. Maybe from A it went to B, or from B it went to A. So, but the final would be equal to the original. Now, the initial charge is made up of the summation of the charges Q1 and Q2. Now, let's say there was some distribution of the charges. So, the final one becomes Q1 dash and Q2 dash. But the total would not change. That would remain. when the charges are connected, their potential would also not change. So V1 will be equal to V2. They are at equal potential. As a result of that, V is going to be KQ by R. Now we are speaking about K into Q1 dash by R, which is equal to K into Q2 dash by R2. This is after they are connected. From this, we could say Q1 dash by R1 equals Q2 dash by R2, or Q1 dash R2 which equals Q2 dash R1. Now let's say keep Q1 dash R2 here. Q2 from our previous equation is nothing but the total charge minus Q1 dash. Let's multiply it by R1, becomes Q into R1 minus Q dash into R1. From this, let's take this. From this we could say that Q1 dash R2 is equal to QR1 minus Q1 dash R1, right? So if we take both Q1 dash on one side, we get this. Let's take Q1 dash common, R2 plus R1 is equal to QR1. So we are going to find Q1 dash equals QR1 by R1 plus R2. Similarly, what we could do is Q2 dash. Q2 dash is nothing but capital Q minus Q1 dash. So capital Q, but Q1 dash is QR1 by R1 plus R2. Where did we get this? We got this from here. We took that and substituted in this. So Q2 dash would become, so let's take Q common. We'll get R1 plus R2 on the numerator minus R1 divided by R1 plus R2. So that simplifies to be Q2 dash equals Q1 by R2 by R1 plus R2. Or Q itself is nothing but Q1 plus Q2. So we can write Q2 dash equals Q1 plus Q2 multiplied by R2 by R1 plus R2. That is the result we are looking for.